Namaste, respected dignitaries, participants, and my dear colleagues. I, Tushar, lecturer, Department of Computer Science, take this opportunity to welcome you all to the Day 4 of the Faculty Development Program sponsored by AICTE Training and Learning ATAL Academy. This program brings together a vibrant mix of teaching faculty, PG students, PhD scholars, and industry professionals from across the Twin Cities. This 1 week offline faculty development program started with the inaugural ceremony led by Professor S. Ramachandran, former Vice Chancellor, Anurag University, and former Vice Chancellor, Osmania University, who also facilitated the session 1, followed by article discussion on a given article and presentations regarding the same, followed by session 2, which was facilitated by Mr. Kadali Srinivas, support escalation engineer at Microsoft, concluding the day with a hands-on demonstration. Day 2 began with session 3, facilitated by Dr. P.V. Sudha, Head and Dean, Department of Computer Science and Engineering, University College of Engineering, Osmania University, Hyderabad, followed by article discussion and presentations. Then session 4, facilitated by Mr. Y. Rajasekhar, Senior Technology Manager at Oracle Health, followed by hands-on session on Microsoft Azure portal. With this, we came to end of day 2. On day 3, session 5 was facilitated by Dr. Nagendra Kumar Suryadevara, Professor, School of Computer and Information Sciences, University of Hyderabad, followed by article discussion on a new article and presentations thereafter, followed by session 6, which was facilitated by Mr. Hanumant Rao N., Senior Vice President, Digital Transformation Services, who also guided the participants in the hands-on session on Power BI, and with that, day 3 concluded. For the 7th session today, it is my honor to welcome Dr. Padmaja Karanam, a senior scientist in agriculture specializing in soils and environmental sciences, currently with the International Crops Research Institute for the Semi-Arid Tropics, ICRISAT. Now I call upon Akhil to welcome our guest with a green hamper. It is my privilege to introduce Dr. Padmaja Karanam. Dr. Padmaja Karanam is a senior Agri-Environmental scientist affiliated with the international CGIAR organization ICRISAT, Hyderabad. She pursued her master's in agriculture with a specialization in soil science and agricultural chemistry from the PJT State Agricultural University, Rajendra Nagar, Hyderabad, and earned her PhD in environmental science from the Indian Agricultural Research Institute, IARI, ICAR, New Delhi, India. Dr. Padmaja Karanam was selected for prestigious international programs on sustainable environmental management at the University of California, Berkeley, USA, and the Research and Innovation Program at the University of Oxford, United Kingdom. With more than 2 decades of experience in agricultural research, Dr. Padmaja has been contributing in areas aligned with several United Nations Sustainable Development Goals, particularly SDG 2, that is Zero Hunger, SDG 13, that is Climate Action, and SDG 15, that is Life on Land. Her work emphasizes a systems approach to enhance agricultural productivity while ensuring environmental sustainability. Dr. Karanam's focus lies in integrating technology and applying innovative and interdisciplinary approaches to address agri-food and nutritional security alongside pressing environmental challenges. Importantly, she brings an interdisciplinary approach by integrating IT solutions and tailoring methodologies for end-user applications. linking agriculture, environment and technology to strengthen food and nutritional security. Now I hand over the session to Dr. Padmaja. Ma'am, please, welcome.
Good morning, everybody. Thank you, the organizing committee of Bhavans, Vivekananda College, to Padmaja, Dr. Sainikpuri, team, Master Padmaja, coordinators, and the coordinating, complete program coordinating faculty. I'll take it from the introduction on the last part where we are all talking about interdisciplinarity. I'm a person with domain expertise in agriculture and environment, and I understand all of you are in the field of information technology. Is that good? Sorry. So, information technology aspiring future leaders, I think I'm interacting and addressing those leaders here, right? Let's make it more interactive. I'm not going to give you a monologue speech and bore you. Is it right? And I can see a good spread of both girls and boys, or men and women, how we call them. So, I think let's get started.
Just a moment, I'll adjust. Closer. It is okay.
You want to do closer?
Yeah, it's fine.
So, how many of you understand agriculture? Everybody understands agriculture? Yes. I think one of the important components for living is, along with water, we need food. And food comes from growing crops. So the agriculture is very important. But let's try to understand what agriculture situation is currently. Agriculture situation is currently, and I'll roll you through that context and see how important is the current topic of cloud technologies for agriculture and environmental management, especially in the drylands. So, as you all can see, cloud computing, what it all means, I think in the past few sessions and your previous experience, you understand what it is. So, we have the connecting points of, if you look at the crops. So, the crops is something, an application area which you people are trying to understand in today's session, but you know the other components, right? So what's really happening is, why do we need to apply these particular tools for agricultural systems and environmental management systems is what I'll take you through. And what really happens when we get some kind of data or some kind of management in the platforms of agricultural production and environmental management, and how that can help us leverage for better decision making, for better production, for better management. Next please. So, as I was telling, these technologies basically they deliver services like the servers, storage software, I think you know all that, over the internet for remote access. That means if you have a farmer's field, somewhere sitting in Bihar, somewhere sitting in some part of Telangana, you can have information access very remotely, and that happens through C. So what are the private service models? You understand those also based on the user needs. Who are the end users? You use these different models and levels of control for the flexibility to meet the requirements of the end users. Who are the end users now? In the current situation of agriculture, the end users could be farmers. If they are technology, if they know about this particular application use, or they could be intermediaries. Somebody like you who will be the future kind of technology leaders, who will be the interface between the farmers and the hardcore software or the technology service. And that's what I was telling. The deployment can happen to the public, the private, and also the hybrid clouds. So what happens is this information which we are taking gets onto these different users, and the best part of it is what I feel about cloud technologies is we have to use the word called cost. That means it is going to be cost effective. It is going to be kind of very well applicable. It is going to be kind of repeatably usable, and it is scalable. So, and its application in agriculture is definitely going to have very high uses and advantages. Next, please. So what are these tools that can help us enhance farming and ecosystems? Ecosystem means, do you understand what is ecosystem? Ecosystem means everything that's around us, eco, surrounding us. So when it comes to agriculture or it comes to the land use, the ecosystems mean all that is present around. It is the natural resources like the water, the soil, the above environment, the below ground environment, all of that. Okay. So what happens by using this kind of technologies? The benefits we have is we have a scalable data infrastructure, and they can handle large data sets from sensors and imageries, and we can help in real-time monitoring and analysis. Before, as I was telling about the points like cars, so this is what the points are, but I'll quickly go through how we can help. It can help in remote access and collaboration. So the farmers or the managers who manage this kind of data, they can handle it remotely, and they can also have remote operations. Like for example, if a farmer is planning to go away from his farm and he has some activity elsewhere, but can he remotely access it? A lot of things are happening in urban agriculture where people have terrace farms, terrace gardens, and they want to go on a vacation, but they are worried they have their plants in the home system, and they don't know if their plants will die because of lack of water. So what happens is, if we have a technology that can help us sense and understand, now is the time the plants need water, then it is connected to the drip irrigation, and what happens is, the water is regulated, and the pots are irrigated. So the plants are taken care of. That is at a small scale. Even at the field scale, what is happening is this kind of sensing and relaying that information, and it gets onto that and to the cloud, and then there is a remote access of information, and this information helps in decision making, and then there is that kind of connecting dots, and then there is a relay response on what is the next action to be taken, and that particular action could be irrigation in the farmer's fields. It's an example. And this will definitely bring down the cost, and it also help in, as I was telling about water management, also about soil monitoring. We will just do a small exercise here so that you understand what exactly is the situation in the farmer's fields or in the soils, and how it can help by monitoring that situation and relaying that information and data, and how decision making can help. So apart from this, also it helps in crop forecasting. And why crop forecasting is very important, especially in the dry lands. I want you to spend a few minutes on understanding what the dry lands are and where we, India, Hyderabad, or the Indian subcontinent is. Okay, next please. So before we, I think you all understand about this, and you probably already had a session on some of these. Do you? Okay guys, please respond. I'm very happy that there is a good gender balance in the group, and I wanted girls to be actively responding to some questions or to the points that I raise, or we can make it more interactive. So I think you understand these points on the Azure features and how the cloud strengths can help in providing that kind of data analytics and for satellite imagery processing. I understand that tomorrow the group will be visiting NRSC, the National Remote Sensing Center, NRSC. So what do they do? I'll tell about that in a bit of a while. But before that, I wanted all of us to pause and understand why should we really do what we are doing now? Why should we do what we are really doing now? Just because we want to do and bring some high technology, is it that? Yes, no? Yeah? There is a need. So what we are trying to do is more like a demand-driven rather than a supply-driven. What is demand-driven? There is a situation, there is an emergency, there is an urgency that we are not managing things better. So how we can manage it better? To manage it better, we need some kind of knowledge, some kind of technology, some kind of integration to make it more smoother and more efficient. So what's happening in the agricultural farms or food production in general? So I think we all know that now India has topped in the global population. Do you all know? Yes. India is number one. We have overpassed China, and we are the highest population in the world. Okay. So what it means? What it means to technology? What it means to agriculture people? What it means to environment people is what I wanted to everybody to think. More people. That means more food requirement, and more pressure on the land. The land is not going to expand. 329 million. You know that area, and in that, in India, 60% is farming, dryland farming, and most of the agriculture contributes to 60% of the total employment or the how do I say, the income generation, the GDP. So that means in the livelihood and in the kind of the scenario of GDP, agriculture plays a very important role. Agriculture plays a very important role, which means the production, the technology should be sufficient, efficient and sustainable, which is very important. Now, what is the scenario of the agricultural land in India? Most of it is drylands. What does drylands mean? Drylands mean that the water and the natural resources are limited. Limited in terms of we have less water, less rainfall. Now there is a climate change. A climate change happening, which means there is very erratic patterns. Like yesterday we had a flash rain. I think it was like almost that the whole city would drown. That was the kind of intense rain. So because of the change in climate, there are a lot of erratic events happening. Either there is a drought spell where there is no water at all, or there is heavy intense rain, temperatures are increasing. Carbon dioxide used to be 300 ppm earlier, now it has become 420 ppm. 420 ppm of atmospheric carbon dioxide is increasing and one of the important greenhouse gas contributor. So many challenges are emerging, and amidst all these challenges, we have to maintain food production. Food production, 2030 are the goals, and what is happening is the food production sufficiency, can we reduce the imports, can we bring quality food in the sense the food that we are producing can be, in terms of quantum it can be, quantities it can be good, but what about the quality? Is the quality being maintained or are we coming down? Yes, it is coming down because we have a lot of nutritional quality requirements also. So there is something called hunger and hidden hunger. Hunger means lack of availability of food. Hidden hunger is there is this nutritional deficiency which are building up a lot, and that is also another type of hunger. So these two components also have to be addressed in the scenario of the changing climate and the weather aberrations and the kind of resources and the demographic pressures that we have. Population is increasing, land is inexpandable. Agricultural land in most of the regions is getting urbanized. People want to sell their farmlands, and that means they want to make it, either it goes into real estate, some industrial development. So the land there is also shrinking. And what is the situation of the farming community? Farmers in India mostly are smallholder farmers. What does smallholder farmer mean? They hold small quantities of land, less than 1 hectare. So what happens is, smaller the land size, the farmer becomes more dependent on whatever that as a source of his income. So there is another challenge of the farmers trying to overdo things, like they put more nutrients, they want to take extra care, and they think if they apply less nitrogen, less urea, maybe their crop will fail. So that's another situation. So the nutrient management and the nutrient efficiency, the water application efficiency, all these things, can we do business as usual, or do we have to do in new ways? That's what we have to think. And in all these scenarios and platforms, we have to address the production, productivity, managing in the changing environments, and sustainability. That means not just for this year, not just for 5 years, but for the next 10 years, for the next 20 years, and probably the vision of 2070. So in all these scenarios, we are existing. Now this is the context and the background, and then what is happening because of the high temperatures and all, the production is going to decline, and it will impact, the climate change is going to impact in terms of higher temperatures, less availability of these food grains in terms of reduction in production. So, and hence whatever we are producing, can we produce it properly, can we manage it properly, can we make it more efficient, is our objective and goal. So how farming can be integrated with smart technologies and make it agri-tech, make it environmental tech, so that it becomes very attractive, and where we can provide these kind of solutions, its applications, we will go to. Next. So cloud applications, next please. So what you can see is these are drones, and what drones do is they have remote access. Through remote access you can operate them, and they fly over regions where we require, and they help us in getting lot of data. They help us in getting lot of data. They help also in farm operations. So here in the context, what happens is when we have to manage our farms, agricultural farms, we have to do something called precision farming. What is precision farming? It's not like putting bulk nutrients, bulk water. It is like you're regulating. Suppose you have, let's say 10 grams of gold. You will use it very judiciously, because now the prices have gone up so much. Similarly, the other inputs like water, if you become a drought zone and zero water, and you just have, let's say 1 liter of water, you have one small pond of water, and you have to irrigate for 10 acres or 10 hectares, how do you do it? You have to do it very judiciously, which is called precision. Precision means you exactly how much the crop needs, you will give only that much water. You will not waste it. I just gave an example of water, but you do that also for other inputs. What are the other inputs? It could be the seed per acre sowing, it could be the nutrient application, it could be the pesticide application, and so on. So with this data analytics, what we can do is, it can also help in crop monitoring. For example, we have some pests which are attacking the crops. So what are pests? Pests could be the insect pests. You understand insect pests? Those are the ones that eat away the crop. For example, fall armyworm was a big case, and where it completely wiped off the crop. Fall armyworm, it came in swarms, so what happens is it totally devastates the field. And can we have some prediction data based on the weather? In particular weather and particular climate, we can forecast and see that this particular incidence is going to, it's a kind of a threat going to happen, and we can pre-vision and we can take a decision. So that kind of opportunity is present present when we are able to sense that data remotely and put it onto the cloud. It helps us for getting some insights, as I told you. And also other things like the crop phenology we call it. Right from the sowing till the harvest, the period of time, when to do what. Those kind of management activities also can be possible, but we need to get that kind of data, and that's where all of you will become the champions, but not in isolation, but in integration with the domain experts who are in the field of agriculture. Okay? And similarly for environmental tech. Next please. So here I come to one very good application, the smart applications of IoT. Everybody knows IoT, right? Internet of Things. So what we do is IoT sensor integration through that, we can have micro-environmental management. That means what? Suppose that's a particular plant or a field, let's say it's a field. We will collect the data, soil temperature, soil moisture, ambient temperature, relative humidity. So these parameters are recorded, and at what scale we need to record also can be decided based on the kind of decision we take. For example, irrigation. If we have to do irrigation for a particular farm, we need to get the soil moisture data. Okay? Soil moisture data. So how do we get that data? If you are sitting in Bhavans college and you have a field 20 kilometers away and you want to know whether you have to irrigate your field or not, what do? Sensors are placed in your field. Data from there is, you get the data which is related to the cloud. From there you get it on your apps. You have a mobile and and there is a prompt that says now is the time for irrigation. Then you say okay, and there is a facility that's already connected and that also has a sensor which says that okay, it goes for irrigation. So we had one very interesting project on automated irrigation control. This was a US-based pay-set fund grant which I was leading and working on. So we all know about solar power, right? Solar power. So the Ministry of New and Renewable Energy Resources wanted to see how irrigation can be more efficient in the farmers' fields, which was integrated to solar panels. So what happened was the energy was supplied for the pumps through the solar panels, and irrigation efficiency was improved by having these sensors, and then you have a control mechanism of when to irrigate the fields. So all this again is to optimize and make it more efficient, right? And then what can happen is, in this process of optimizing, we are also reducing the wastage and we are bringing in more efficiency. Next please. So crop forecasting and pest prediction, as I told you. So what happens is, constantly we need to have some kind of monitoring. Like for example, the remote sensing analytics, what happens there is, those satellite imageries with that, you all know about spectral reflectance. I don't know if you've heard about those terms. So basically, it's mostly based on the color images, what you get, the reflectance, the absorbance and the reflectance. Based on that, the imageries make the decision. So for example, you have a imagery, one satellite imagery which shows red color, it shows green color. If it so there is a tone indication telling that red means vegetation, blue means water. Example, suppose there is a yellow patch, it means it is a barren land where there is only soil and there is no crop. So that is the information very broadly, roughly I have told. So that imagery is taken at what frequency and level. So much of data keeps flowing in, and based on this data, what happens is we are able to use that data, do the analytics and helping for prediction, and also different users, like it's not just the farmers or the decision makers, also for the policy, and it's also for the researchers who can understand what are the patterns happening. Like for example, in past 10 years in Hyderabad, the rainfall onset has shifted from June and moved to August first week. How can I say this? I look back at 10 years of data. 10 years of data at what frequency? Every day in the last 3 months, over a period of 10 years, that kind of data is taken, how it is drawn. So we need to have some kind of sensors. In the field, we have those small IoT things, but in the larger picture, we take the satellite imageries, we use them, and we try to analyze them. So those analytics can help us understand and predict. So this is what is going to happen. Next year also, the rainfall will not be in the June first week, maybe it will be this, based on so all that monsoon prediction in your mobile, if you open, you find that no, today there is going to be a sunny day, bright sunlight, 2 hours, cloudy, 8 hours, all that, how is it happening? So it's all this, right? So when it comes to forecasting for crops and pest prediction, that there is going to be a possibility. What happens is these data help in better decision making again, and the future is not just cloud computing and all, but it's going to be integration with the AI, right? And for AI also, what is the source data? So whatever you feed in, that's what comes out, right? If suppose in online information you have good quality data, then AI is able to analyze that and then predict and say this is what it's going to be, right? So, for example, I talked about the fall armyworm, which was a very important and is being a very important pest problem. Similarly, we had this locust problem also, and it just came, you know, like from the northwest Rajasthan region, moving from Pakistan. So that's, you know, these pests do not know any country borders. They just come in swarms, and that's how they came and attacked it. So that's like a disaster alert, and we can get these alerts in advance, and can we do some management. So for example, if we know that the particular pest problem is going to happen exactly in July 2nd week, can we do a decision of postponing or preponing so that the crop stage is adjusted, thereby you are escaping the pest problem. So for individual farmers, you can have mobile alert platforms, and those information can help them recommend. So the farmers know there is going to be rain in 2 days' time. So what does the farmer do? The farmer will prepare his seeds, he'll prepare his field and keep it ready. So accordingly, he does that planning for his farm. And so because of all this, you know what happens, it is more so important in the drylands. In places where there is plenty and sufficiency, people need not worry. Suppose you have, let's say, a rich source of 10 lakh rupees. It is there for each of you. Then you will not bother for 500 rupees, 200 rupees or 2000 rupees. Why? Because you are resource sufficient. But suppose somebody takes away your 10 lakhs and says that you are left with 1000 rupees now. You have to manage for 1 month. What will you do? You will manage every rupee. So that's what is an example. I am just drawing an analogy of what happens to the resources in the farms. Next please. So, next please. So what happens is, I talked about the drought conditions wherein the rainfall is less than the normal, and it leads to a dry situation, which is definitely going to affect the crops and everybody, because water becomes less and there is high temperatures. So these are some of the characteristics of drought. So what happens is these data sets that you collect over a period of time, they help in simulations, and these simulations and forecasting, with that we can kind of predict and develop models and say that okay, this is going to be the scenario 1, this is going to be scenario 2, and this is what we have to plan, right? So I talked about weather assessment, I talked about early warning system and how it supports the dryland. So it's all interlinked and tailor-made, you know. Suppose the point 1 you're able to manage your resources well, then the crop grow better, the yields are better, and you're able to make it higher production, higher productivity and more sustainable. Next please. So it's not just about the agriculture. This particular thing is also important for forests and rangeland monitoring. What is rangelands? Those are where you have this livestock, you know, they go for grazing. So those areas are also can be monitored well. And the importance is that these components, forests, forests are one of the primary things of managing our environment, right? Do you agree? The moment you have cut down of forests or trees, what happens? Can anybody say? What happens? Temperatures will rise, rainfall will reduce, it will become more drier. So what is happening? You all understand the elementary thing about photosynthesis, right? Photosynthesis happens where carbon dioxide from the atmosphere is taken in the presence of sunlight to form carbohydrate by the plants. So that is the process cycle. In the food pyramid, for everybody's food, you need plant-based food or animal-based food. In the food pyramid, if the primary production, that is the photosynthesis, is affected, the whole food chain is affected, is it not? Suppose the food production is affected. Food production is affected if there is a impact on the environment. What is the impact on the environment? If you are cutting down forests, if you are not able to maintain that kind of green cover, the carbon dioxide from the atmosphere is not being captured. So what happens? It has a global warming potential. The temperature increases. That's what is climate change. Climate change or the global warming phenomena. We are talking about the global warming phenomena. The phenomena causes impact is the climate change. So the global warming is happening. Carbon dioxide levels from 290 to 80 ppm have gone up to 420 ppm. It is also likely to rise further. And if the temperatures, if this rises, the global warming is going to be higher. We also have nitrous oxide. We also have methane. We also have chlorofluorocarbons. So these are some of the important greenhouse gases which are contributing to the environment. Now what is happening in the environment and what are their levels and concentrations, how we can do? We can get this data by monitoring. The environmental monitoring we can do and get this data onto the cloud platforms, and how we can help make use of that technology for decision making and understanding the scenarios and what are the predictions, what are the trends happening in the current. For example, let's say you have a patch of 10 hectares or 100 hectares of forestry. You have done plantation. By doing that plantation over a period of time, after 1 year, what is the microenvironment benefit, or what is the change in the levels of carbon dioxide, what is the change in the levels of nitrous oxide? Example. So we can have all these data. All these data just on your simple computer. Is it possible? It's not possible. So you need larger platforms where you can store all this data and you can access it remotely. Somebody is sitting in the NASA, they use NASA imageries, NASA satellite imageries, and take that data. Where is that happening? Somewhere. And how you're sitting in Hyderabad and you can do the decision making based on that remotely accessed and remotely recorded information, and that is which is helping in our modeling and new science. Okay? So I think I covered on this, and next please. So FAO is Food and Agriculture Organization. Food and Agriculture Organizations, what they've done is, I told you drylands are all that negative things. Have anybody seen Rajasthan? Rajasthan is a highly arid region in India. And just to tell the audience, India is having diverse agroecologies, diverse ecological regions. You have a humid region in one place, you have a very dry climate in another place. You have a desert in one place, you have a rich biodiverse regions like the Kerala in another place. So you have a balanced plateau kind of Hyderabad. You have a very cold and high altitude regions like J&K and Himachal. I'm just giving you examples. You have 2000 mm rainfall in the Assam region, and you have 300 mm rainfall in some regions in India. So, in a way, India has got a great platform to understand how different agroecologies or different ecologies are there, and getting that data for localized decision making. Like for example, for the state of Chhattisgarh, for the state of Arunachal Pradesh, for the state of Rajasthan, for that particular localized agroecology for the whole state, if you can get that kind of data, so integrate, use the data, analyze the data, and help it for decision making for whatever regions. Here we are talking today about agriculture and environment. So FAO, what it is doing is, on the forestry initiatives, it is trying to make use of the cloud platforms to understand, and also to, so there is something called data training. You all understand, right? Data training, yeah. So, and also for sharing this kind of data for forest management in the drylands. CGIIR is a consultative group of international agricultural research. So what very concerned is, it is a global thing and it has about 16 centers across the globe, and ICRISAT is one of the centers, and ICRISAT very specifically works on the International Crops Research Institute. It works on mandate crops, that is millets, which everybody are talking about. We should shift from the cereals like rice and all and go to millet cereals. ICRISAT works on pearl millet, sorghum. Okay, it works on legumes, pigeon pea, chickpea, ground, and it is also working on ragi and little millets. So why these particular crops? These are actually climate smart crops. What are climate smart crops? That means they can survive, they can do better even in dry lands. What are dry lands? With less rainfall, with less, everything less. So they are like the poor people. Dryland regions are definitely characterized by the resource poor environments. People are also poor. So marginal farmers with less land holding, the soils are not fertile. So in the olden scripts, there used to be a kind of a saying that those civilizations flourished where the soils were fertile. What does it mean? If the soils had rich nutrients, it was able to also hold the water. So once the soil is good, it can hold water and it can really help the whole crops. So the soils, the below ground environment for the crops is one of the important component. And so where the soils were fertile, those regions flourished. Now the regions like the drylands, from where things washed off and went to the sea, these are poor and less fertile soils, thereby the regions also cannot hold moisture and they are all in the deficient zone. So how adapting to these particular climates, and ICRISAT works on bringing these particular crops in the forefront, and different technologies of crop management, soil management, water management, environmental management, along with the seeds, along with the environment. So it's totally like the, how should I say, it's the soil, the crop and the environment. Below crop and above environment. Okay? Around those areas ICRISAT works. And not just with that, but also with people and their social equity, reducing hunger, on building the sustainable ecosystems. So we also have some digital tools which we have developed, and we try to integrate mobile apps and dashboards to support farmers in the semi-arid region. Next, please. Yeah. Here. Next. Yeah. So in this, as I told you, one thing is you have this on your mobile, and the situation is we can do a weather forecast. Whether there is rain, there is going to be rain, then you don't apply a pesticide. What happens? You apply a pesticide, you spend 1,000 rupees per acre or hectare. There is rain, everything gets washed off. So that decision making is possible with the weather forecast. There is going to be rain, then you apply a fertilizer, like for example in the soil, it needs rain, then the crop will be safe. So also on the AI powered insights, what we are trying to do is this sensor data. For example, you have a soil moisture sensor or soil temperature sensor. It records every 15 minutes or half an hour based on whatever kind of duration and interval you want it, and you get that data. That data over a period of time is collected, and it will help us understand on the productivity and reduce the risks. So it's not only important that we understand how these all are, but we should also have people to be more capacitated, and knowledge sharing should happen. Like for example, this is a small group who is trying to understand through this program on different technologies. Similarly, this knowledge sharing and technology dissemination and capacity building. So you're all getting capacitated through this training program on this particular topic or in this particular course. Such intensive capacity training programs need to be conducted so that you understand the importance of integrating and what is the domain applications possible. Next please. So I talked about most of them. The satellite imagery, tomorrow in detail you will try to probably get an understanding of what exactly they do. So NRSC does the complete, it's not just agriculture, they do it for everything. For example, if you wanted to get some situation of the traffic. So if there is high traffic, low traffic, how you are able to know? It's again the imageries which are giving you some picture, and the Google Maps are helping you understand, okay, there is crowd, it shows a red line, don't travel on this road. So these kind of things are remotely being sensed and helping in decision making, and so the prediction is happening, like for example, if you have to travel from point A to point B in a period of 1 hour, but because of the delays, you will reach in 2 hours because there is a red line. What happened? There is a big traffic jam. So this kind of analytics and decision making and prediction, not 1 hour, now you will take 2 hours to reach. It's happening how? Because of the data. And thanks to this particular technology and ideation and innovation that we have to put everything together to come up with that, the solution looks very simple. Okay, you are going to be delayed, you will reach only in 2 hours. How did it happen? Lot of work behind, right? Okay, so that's what it's all about. And in the fields, actually there are a lot of complex challenges because agriculture it's not a simple science like in the lab, You just have everything very controlled. You have your glassware washed and you put particular solution, you say 100 ml and then you put a particular reagent and you do some titration and then, so you know exactly what are the components. But in the environment, it's very complex. It's an open thing. Still, in that complex environment, we are trying to get these information data packets and we are trying to integrate that for decision making. Okay? So, these dashboards can help in data integration, performance monitoring, analytics and resource management support. Next please. So, now we've understood all this. How do you think you can make this service more applied and more smarter? Like for example, if I had a piece of agricultural land and I was supposed to continue farming, then I would not find it very very attractive for me to continue it as a career. Is it right? If you had a piece of land and you have, let's say, 2 acres of land and it's a good land, but you are educated or you went to college, university and you studied, you don't want to, do you want to continue, go back to farming? The old conventional way of farming is very boring, unattractive, and maybe it will not improve my profile. If I say I'm a farmer, nobody will like me. I'm a farmer, she's a farmer. But I'm just putting that context because now farming is not just going to be farming, it's going to be tech farming. It's going to be smart farming. So what is smart farming now? If I go to my field, I'm just not just going with a plow. I'm not just going with a pipe for irrigation. But what I do, I am going to the farm with a pad, with a phone, with a tab. That means I'm going with technology. So the technology is an attractive thing for me and also for us. So what happens is technology integration into the domain space of agriculture makes it more smarter. The process also becomes smarter and it makes us more, it gives us a lot of insights and it also improves our profile. So what I'm saying is this is the next future. The future is all the IT people who are resigning from their jobs are telling that I will do part-time, IT part-time, full-time tech agriculture. So technology integrated with agriculture makes it more attractive. So such cloud technology courses and platforms can help you enrich and understand more about how these can be integrated, what are the situations and scenarios. See, you all are experts in programming, coding and doing all that and understanding the systems and where you have to integrate. But the end user here is the farmer. So working with domain experts like us, so we will tell, look, you all don't understand what is soil, what are soil types, what is the moisture level, when the crop requires water, when the crop requires fertilizer, when the crop requires pest spray, what is the pesticide spray. These components the technology people or IT people are not aware of, because that's not their subject. The subject experts and the domain experts, like us for example, we know the complete story of the crops and we understand what it is. So when we say, can you give me a irrigation scheduling app? Then what? Then you will ask what does it mean? Then we say that okay, at this particular stage, this much of water irrigation has to be applied. And how do we know when it has to be applied? Then I'll tell them further conditions. So in soil we have something called saturated condition, something called field capacity condition, something called permanent wilting point condition. So what are these technology terms? You people won't understand. What it means, saturation means, I'll just show you one small example and we can understand that. So that's how the integration of cloud computing technology, its applications in agriculture becomes very helpful with a meaningful integration of the domain experts. And these training platforms can help you understand for better agricultural applications. Also, hands-on lab and certification process. So these are some training platforms which you need not be directly technology developers. You can understand this subject and concept and you could be the next level. Like, you know, you can become training of trainers. So this is again a very interesting career path or a course path which you can plan to take, right? Okay, about capacity building, I have told you. So the farmers, some of the educated farmers can also become technology farmers. But if they are not there, then the farm managers who are IT and a little bit of agriculture knowledge based people become the intermediaries. Next, please. So before we go to challenges and ethics, or rather we'll do that and then we'll do the experiments. Do you want a water break or bio break, or you all good? Are you all good? Good. So if you want water, you can drink and come, that's okay, I mean, that's up to you. So, okay, we'll close with this and I want to show a few things which will make it more interactive with the group. Please continue. So this story is not so easy. It comes with a pack of challenges and also responsibility, ethics. So there's a lot of data that is coming. So data privacy and ownership is one aspect which we need to consider. So ethical data handling. And if suppose we are getting some information, how we ethically handle it and rightfully use it is also very important. Because we are in this training course, I thought we should also have a few tinkering points on these lines. And so it must be properly protected and maintained. So it's more like responsible management, right? And then regulatory protection of this data that is being collected. So actually proper frameworks to safeguard the user rights and prevent misuse of this sensitive information. For example, let's say you have information on the open information from the imageries, let's say. From the imageries, let's say it gives all kind of information. So there could be some security sensitive information also, which need to be, I am just giving an example, which should need to be properly protected. So that kind of safeguarding information for security purposes is also very important, right? And it's transparency and consent. So when using the data and also for building trust, that kind of consent, taking consent. Let's say this particular data is developed or generated at Bhavans. So there is something called permission, consent, etc. Only then it is given. Like for example, as you heard about ISRO, NASA, NRSA. So they have a lot of data. Some data is open to the public. Some data is to be through permission and through consents. So there are some different layers which everybody has to follow when it comes to the data use. And So protecting the data privacy is very crucial in vulnerable dryland regions to prevent exploitation. Like for example, let's say that we know that there's going to be zero water or zero rainfall for 3 weeks or 4 weeks in a particular region. So the private sector or some private players should not misuse that information and say that, okay, they start raising the prices for water supply. I'm just giving an example. So these kind of scenarios should also be taken care of. Next please. So it doesn't come with a simple bundle of just the technology and all. There are also some infrastructure gaps. So what happens is internet connectivity, if there is a limitation, then we are challenged by that, and power supply is another reason. So which is why now I think the concept of integrating with solar power is very important for countries like India, where we have ample radiation, solar energy. And also this comes with some investment and a proper policy, so that the infrastructure, the capacity building and those things are properly supported through investment, and also there is a supportive policy for that. And so what happens is, suppose we are taking the data and becomes very large data, then we should also be able to make it localized for localized applications. So these technological solutions should also be used and then customized and make it more local. I'll give you an example for that. For example, offline data collection and edge computing offers practical solutions for bridging technology and access devices. So this is the kind of edge that CT has. So what I'm telling is, suppose you have data for a bigger region. That data is not customized for a smaller region. Then what happens? The same data, without kind of customizing it, if we try to apply, it doesn't work. So what you have to do is, data has to be customized, fine-tuned and then prescribed or recommended. So in that kind of advisory also, this localized solutions have to be provided. For example, somebody has fever, they go to the doctor. Doctor says paracetamol, Crocin, paracetamol, Dolo, etc., whatever. He gives that tablet. He says, okay, you take one tablet in the morning, one tablet in the evening. Dolo is 650, paracetamol is 500 mg. Now suppose a body weight of a person, based on the BMI, actually he has to customize the drug dose and then recommend. So what he says is, suppose the person is below 14 years, below 12 years, then there is a child dose. In the adult, based on the body mass, he just looks at the patient and says, okay, for you 500 mg is enough. Suppose that's one aspect. Another aspect is the intensity of fever. If it is very high, we say, okay, you take 650, you have to take 650, otherwise it will not. So what is happening there? The example I'm trying to say is, you're customizing your solution and giving the solution or recommendation, right? Next please. I talked about costs, infrastructure costs, the costs and barriers. So sometimes, for agricultural scenarios, for small farm holders, this kind of costs may be very high. So what has to happen is, the governments and the intermediaries have to come in between, who can get the data for the small regions and then thereby make it more accessible to the farms, right? So cost barriers are there, and we need supportive solutions, because open source alternatives and subsidized programs can help reduce the costs and increase the access to the city, the technology. And as I told you, the governments and the NGOs, they have to come into picture to promote equitable and inclusive access. So what happens is, it's not the predominant alone. Everybody, equitable means everybody, whether he's a rich farmer, a poor farmer, a farmer who is educated, uneducated, everybody should have equal access to that particular technology solutions which we are providing. So that's where the government comes into picture, and we should also make sure that this particular technologies become more affordable and they are inclusive, right? Yeah, next. So the future trends, I think after CT, what next? What next? As I was telling, AI and cloud integration is there. So I think this probably Dr. Saraswati can explain better. Here it's about AI-driven data analytics and how ML algorithms can help analyze large data sets to provide predictive insights. So you're just not just doing with cloud technology alone, but you're also integrating AI into the picture. And as I told about modeling, so we do a lot of modeling, predictive modeling. AI will also, so basically the algorithms that are developed are based on the historical data that we get over the past 10 years, 20 years, 30 years. So that data is fed into, and then we develop those algorithms, and then we can help in different applications, like it could be weather forecast patterns, crop diseases, and thereby optimize resource use. So the cloud computing support can offer the scalability and the power of computation, which is essential for deploying AI solutions in agriculture. And all these can help enhance the sustainability. What is sustainability? Sustainability is not just for now, but to be able to do similarly better over the period of time, sustainably longer period of time. So that's what it is. And so if we are able to bring that resilience to bear the shocks of climate change, to improve the productivity, and to make it more sustainable over a period of time. So that's where the leaders in cloud technology will all be appreciated and will be regarded. However, next please. So blockchain for traceability. So what is traceability? Like for example, if there is a pesticide, now we are seeing a lot of health issues happening. So the pesticide use and where exactly in agriculture, I'm just giving an example, in agriculture, where exactly this particular material moves into the system, in the food cycle or into the environmental system can be predicted. Some examples are also in the broader end. The invisible part I was talking about, like the ones that are present in the food grains, for example, the pesticide molecules that get into the air. Once you spray them, it get into air. Where exactly they move in the ecosystem? They go into the water, they go into the food grains, they are also in the air suspended, people breathe in. So these kind of information is possible when you have that data recorded in different platforms. Like, are you doing atmospheric monitoring? Are you working on suspended particulate matter, for example? Are you getting that data over a period of time? That data can help you understand, okay, there's a lot of sulfur dioxide or sulfox in the air, and this is the problem. So pollution, what is the carbon monoxide levels in the air? So these are certain things of data which you can generate by recording it over a period of time, and you can get it. In agriculture, the major macro part of it is traceability using blockchain technology. What happens is here, for example, farm to market. There is an orchard, a perishable fruit like apple or something, and then it goes to the market. Can you do that traceability? And also, if it is, people are talking so much about organic food. Organic food, is it really organic? So is it that certified thing from that particular farm? So we are able to trace that whole thing, right? Fair trade is a similar concept where we are talking about what we do is kind of we reduce the intermediaries. So brokers are reduced and directly farmer and the consumer are put into contact. And supporting farmer cooperatives. When farmers individual farmers cannot, then how blockchains can help in farmer groups for improving the market access and real-time data sharing. Next please. Edge computing, I think that article discussion is something on that. So, yeah. Thank you. But before that, let's all do a small exercise. I have requested the organizing team to provide me with some soil. Please be there. We have another 10 minutes. So all of you have seen soils, right? In how many colors soils have you seen? Very good. I'm seeing good response. So you're all active. Red soil, black soil. Okay. I have two. Thanks so much. I have two soil types here. This is sand. Sand? Yeah? So, this is red soil, mud. What do you think is the difference between both these? I also requested for a pot plant, this one glass of water or one mug of water. This one, no, drinking water. So, tap water. So, this is soil, different types of soil. So, the whole control mechanism of water, irrigation and monitoring and all your cloud technology and all starts with the fundamental thing, the soil. Soil, if the soil is something like this, what does soil consist of? So, let me just quickly brush you through the things. Soil has three components, three particles, particle sizes. Sand, silt, clay. Okay? Sand, silt, clay. Three different component particles present in the soil. If the sand content is high, it's called sandy soil. Thank you. So, if it is moderate, it's a red soil. If the clay content is high, it is called a black soil. So, it's very sticky. It is black soil. That means it has clay particles like montmorillonite, vermiculite, different kind of clay types. Those are the names of soil, the particles. So, generally, what does the soil consist of? Soil consists of the soil. It also has air spaces. It also has living microbial. Something else also is present in the soil. So soil is not dead. Soil is a living, it's a living platform. So what it has? It has the physical parameters like the physical traits like the sand, silt, clay. It also has air spaces packed in between, and it also has carbon, organic matter, which is carbon, and it also has microbes. So these are the different things that are present in soil, and the right composition helps in better crop production, better crop growth and all that. So this particular soil type has got a little bit of moderate levels of the silt and the clay. Sandy soils are mostly sand and don't have those holding things. So what happens? Now for example, I am just measuring a imaginary quantity, I am just pouring it into this glass. So what happens? So there are macropores. So there are micropores and macropores, two types. So the macropores are the bigger pores. Macro means bigger pores, and these pores get filled into the spaces. So it replaces the air spaces and fills up, the water fills up here. Okay? Now, in sandy soils, because they don't have the water holding nature. So what happens is, if I put a hole on this, all the water will come out. If there is a pot and we put water in a sandy soil, all the water will come. Why? Because it's unable to hold the water. Now this has some amount of clay and moderate and silt. I pour some water. So here what happens is, in this particular soil type, when I pour water and I put a hole, not all the water, let's say I put 100 ml of water in this and this. In this probably 80 ml of water comes out. In this probably 50 ml of water only comes out. So what it means to agriculture, if the soil type is not able to hold the water, there is rain, it is not able to hold the water, water runs off, water drains off. How it goes off? Either there is a surface runoff, water moves on the surface, it goes percolation, vertical movement, it goes down into the soil, percolation, it goes and maybe there is a water body recharge happening at the ground level, that could be possible, or there could be lateral movement of the water. Water is moving somewhere, but if it is having some clay or some holding or some barrier, water will not move away easily. And the micropore component in the clay or the red soils is higher. So the more the micropores, the better is the water holding or the WHC, water holding capacity. Now what happens is, when we talk about IoT sensors, what we are doing is, we take a sensor and put in the field. So these sensors are recording at regular period 24/7. At a particular interval, they are giving us temperature, they are giving us soil moisture levels. If the soil moisture level comes down to field capacity and below. What is field capacity? It means that water pores are vacant, but there is still some water. And saturated condition, what I told you, there is full water. So suppose you have that sensors placed in two different soil types in two different locations, and it is able to give you data. What is the data you are getting? In both I would have given 100 ml of water, but what it says is after one day, the sandy soil field will need an irrigation, but the red soil field will not need an irrigation because it still has water. So once it goes beyond that field capacity, it's called permanent wilting point. When it comes to that point, what is wilting point means the plants don't have any more water, so there is no transpiration happening. What is evaporation? Everybody knows. Evaporation is loss of water from the surface of the, through evaporation. What is transpiration? Transpiration is the water movement from the soil through the plant into the atmosphere. So when there is no water available for the crop, what happens is it becomes a stage where it gets to the permanent wilting point. The recovery of the crop is not possible. So which is why an irrigation decision has to be made that you need to irrigate that particular sandy soil now, in the next 10 minutes, in the next half an hour, in the next 1 day. Otherwise you're going to lose your crop. Otherwise there is going to be a penalty on the yield, there's going to be penalty on the crop. So these are the kind of decisions you can make by having simply sensors in the soil, in the fields, and get the data, and that large amount of data that keeps coming at regular intervals, you can make the decision and say, okay, look, this field needs it. I just thought I should give an example so that you understand. And the importance and the beauty of this whole thing is the technologies in integration with the domain specialists like agriculture and environment can make the journey of advancement much better, much faster, and much more rewarding. So here I invite the future technology leaders in cloud technology or the other advanced technologies that keep coming, I mean from the IT side, to look into integrating with the domain specialists to make more innovations and come forward with solutions for a better food, for a better planet. Thank you. If you want, you can do, I don't know if you have some sensors or something. You can do some experiments with pots by forming groups. Do you want to do for 10-15 minutes? Okay, I'll be happy to take any questions. This is very important. I thought you should have an interactive session, right?
I encourage everyone to ask any questions that you want.
Yes.
Ma'am, we see like in other countries, they use lot of advanced equipment for doing irrigation or farming or whatever. Why are those not like machinery brought to India?
Okay. So, can you please introduce yourself?
I am Dr. Ratna.
Ratna, you're a lecturer?
Yes, I am.
Okay. Can you give more details? You teach?
And I teach computer science.
Okay. Okay. Thank you for that question. So, you talked about a case scenario where advanced technologies are being used in other countries, but why not here? Definitely, you know that we are still in the category of developing country to better developed country, and we are an agrarian economy, and the technologies have to become affordable, which is what I was presenting. So, for example, in the West, very much in places where there is labor shortage. So, how can you do that kind of irrigation and decision making on the crops, spraying for thousands and hundreds and hectares of area with the kind of less available labor. In West, I've seen some farms. I was talking to the farmer I asked him how much land you hold, and I was surprised. He said about 900 acres. I said, what? 900 acres? And how many people do you have to manage the farm? He said, just 2 people. I was even more surprised. I said, how can you manage that? They say, we have it. So machinery and mechanization is another important thing. I wanted to tell you about John Deere is a company which does a lot of this data, they capture a lot of field data and they use it for modeling and for farm applications. Like for example, in agriculture there is something very important called leveling. When you don't level the field, what happens is there is undulation in the soil. So when the land platform is not level, in one region there is a water inundation or the water gets stored and it gets flooded in one region, another region is dry. So the part where there is no water or it is dry, the water that would have drained off, there what happens is sometimes if the water is in good condition, good requirement, then the yields are not affected. And the places where it is fully inundated or flooded, there is a lot of water stagnant, then the crop yields are affected. I'm not talking about paddy, but for example, groundnut. Groundnut is a underground crop, and if there is no proper drainage, then the crop yields are affected so much. So these technologies on laser leveling, machine-based things, so they have something like an all-in-one machinery where they do the soil, they do the intercultural operations, they do the harvesting. They also not only do the harvesting, they also do the segregation, that is the straw with the grain. The straw is bundled, the grain is poured into those containers. It's also packed. It's like a factory, and then you have the thing. So one thing is about affordability, and then the advancement. So but AI and the cloud computing and the technology application making it smart agriculture is also happening in India, and it's happening at a faster pace. So there are a lot of startup and tech companies coming up with digital solutions for agriculture. So that's where I see a good future for technology people. We are there, but we are not yet there. We have entered, but I think we have to catalyze and move it forward. This can happen only when you are able to understand the importance. So you all know that now each of you feel that you are one important leader because you have understood that how important agriculture is. So the food that is produced, every kg decline of yield in the bulk, how much it would be a decline. Just imagine a farmer's field, instead of getting, let's say, 20 quintal, a quintal is 100 kgs, 20 quintals, he is getting only 15 quintals. And that is happening because of certain poor management practices happening in the field. If you can improve the efficiency and bring up that yield, 5 quintal difference, from 15 to 20, if you can optimize and bring that increment, that 5 quintals into so many thousand and lakh farmers, how much you are contributing to the food production. So that's where I see, and I think we are catching up, because IT, you all just, for a minute you pause and you see where all IT is being used. So generally IT, you people say, so a lot of software companies. Can somebody give an example among the participants, like where you see people say that we are all IT developers, we are programmers, we are engineers, we are leaders, we are all software directors. So with your own imagination, there is no restriction, but can you just tell where all your applications, don't talk about agriculture, but generally, majority is not agriculture. So can you tell where all these applications are happening, and how do you describe your profile? Okay, can I ask somebody in the boys row there? Husband too, students, sir? Okay. Anyway, can you stand up and please speak? 2-3 people also, please be prepared. Very quickly, let's finish this topic. Yes.
My name is Rajkumar. So I am also working as an assistant professor in computer science department from Vivekananda. So most of the times we develop the applications for like banks, insurance companies, healthcare, hospitality, airports, airlines. So most of the times we focus on those areas.
Okay. So what I heard from the participant is, it's healthcare, it's hospitality, it's banks, finance, lot of finance related things, government departments, and examples of hospitality, example of healthcare also. So much computer related. So for example, in the marketing, in the manufacturing of bulk manufacturing of certain pharmaceutical, how much of lot of computer technology is being adopted. Any more examples which he has not covered? Can somebody? So why is it that these technologies have picked up? Because they thought it is easy to adapt, easy to start with, and the importance and need and the wider requirement. Healthcare is a big. Everybody needs healthcare. Travel, everybody needs. So those kind of sectors, finance, banks, everybody uses it. So those kind of sectors have caught up in the beginning. But now we also understand that agriculture as usual is not going to help, because we're going to have a lot of problems, and these challenges we have to address. And how do we address them? By integrating these technologies. Can we make it more data driven, and can we do that analytics, and can we help in improving the decision making? For example, in the recent news, urea, lot of demand and there is no supply. So if a farmer is given, let's say, only 25 kg of urea, how can this technology help in making that decision making? Say that, okay, you apply only this much in this quantity and this times through the crop period, so that you save your time, you save your crop, and you also save your money. So this is what I see. Yeah. Any more?
No question.
Yeah.
So you have seen two types of soils, right?
Yeah.
Soil and
Yeah. These are not just the two soils, we have many soils.
yeah.
Okay.
So are there any kind of mechanisms or techniques that so that the sandy soil also can be converted into red soil?
Very good.
So that you can have you can reduce the portion of drylands.
Very good. Great question. Thank you for asking that. Actually, I work on something called carbon farming. So what happens is, sandy soil is lacking the organic content or organic carbon, the clay content. So can we improve these sandy soils into better soils? Very good question. I am really happy that you asked this. So keep growing crops. So what happens is, once you make it more vegetative, or there is something vegetation happening on that, there is the root system. The root system goes into the soil. There is a lot of things, the biochemistry that happens in the soil. Root exudates, there is a rhizosphere, the root region is called rhizosphere. So it improves the overall soil health because of the plant. That's why I would recommend everybody that whenever you get a chance, please plant some trees, plant some saplings, please grow something green. Anything that is photosynthetically active, please grow. So what happens is, you're improving the air quality, you're also improving the soil. So over a period of time, as you keep growing, what happens is the soil carbon keeps building, which is called carbon sequestration. So sequestering the atmospheric carbon dioxide through plants into the soil, the carbon sequestration happens, and this sequestration helps in building above ground biomass and below ground carbon. So the carbon that is held in the soil is being talked about so much. So what is happening is, for example, highly polluting industries, any industries, they say that we are trying to become carbon neutral or net zero emissions. So what they do, their companies, they can make their buildings a little bit green and say we can reduce our emissions by this much. But what they are trying to do is, they are going to buy carbon credits from the farmers. That is the future technology. So the future technology is, farmers who grow crops and are able to build the carbon in the soil or through their biomass will be given some incentives or credits. Let's say if I have some amount of carbon built, and there is a whole lot of mechanism. If you see carbon farming, you'll find the story. So the carbon being built, the farmers are benefited through small incentives. Maybe they are given 2,000 to 4,000 rupees per crop season. So that way, these credits are being purchased by the industry. So the industry directly cannot involve. What they do is, the industry will buy the credits from the green growing, whether it is the forestries or it's the agriculture crops. So what happens is, the carbon building can happen. It is possible. And these mechanisms can happen only through farming, through forestry, through green vegetation. Okay? So if you keep growing in a sandy soil, after 10 years you can visit back and see how the soil is.
And last question.
Only you? You want to do a hacking? I thought I should give a chance to somebody else.
See, Actually, we do have some farms. So I go every 15 days to my village and I will see what is happening there actually. So when I went for the last time, my father was actually, he was using pesticides. Anyway. So I have Kalimandu. So I have questions in like Kalimandu Kotinapuru, that will not affect our soil.
It will affect us.
Then is there any other alternatives that we cannot go for the pesticides, so we can use some natural things in order to avoid soil erosion and all.
So pesticide or weedicide, he told about kalpu means weed. Plant out of place is called a weed. For example, you're growing a sorghum crop or you're growing a maize crop. In that there will be some other plants which are called weeds. Now these weeds will attack, or rather they will interfere with the growth of the major crop of our requirement and will compete for the yield, compete for the growth, and this becomes a nuisance. So what the farmers do, they try to remove it off. So there are different ways of managing the weeds. One is mechanical methods, the other is chemical measures, what your father was, you talked about weedicide spray. So
actually chemical measures they are using.
So everybody is encouraging organic farming because there are alternatives to chemical methods. So can you do, there is something called mulching. Is it possible? It's not possible in all the fields, but in some fields it's possible. In paddy it's not possible because paddy has got stagnant water, that's one method. The dry method is also there. But managing the weeds needs an integrated approach again. Pest management, disease management, weed management need an integrated approach where we can reduce on the chemical requirements and adapt on the management practices, the styles of growing crops. And see, for example, if you are growing an upland crop like maize, if you do intercropping, then you can reduce the weed incidence. That's one method. Crop rotation is another method. So there are so many such things, and it's a whole list of, there are bundled technologies for different crops and requirements. Yes. Quick, please. University of Hyderabad, you are a student? Elaboration is not possible, but I'll try to brief. Okay? So, for the benefit of the audience, I'll speak in English and I think you can understand. So, he asked a question about shifting away from chemical farming to organic farming. Chemical farming is what? It is chemical intensive, input intensive farming. Organic farming is organic based, organic sources, naturally available material. For example, we use something called neem based pesticides, neem oil based pesticides, and those are organic. I'm just giving examples. And instead of using urea, can you use farmyard manure? Can you use other organic plant residues incorporation? So those are organic sources of nutrients. Two examples. Now, if we have to move from chemical to completely organic, a overnight switch and saying that my yields should not be reduced is not possible. So you need to give a staggered, it depends on the soil. If your soil is this type, and you tell me that I want to go organic, next year you will be at a zero. You will put 1 lakh, you will get 0 rupees back. So what is the reason? Because this soil doesn't have yet the resilience to build up on organic. So you have to have a staggered reduction. Until 80, slowly you will have to shift by using chemical and organic, slowly reducing the ratio of chemical and increasing the ratio of organic. So some evidences have shown that 3 to 4 years. But again, it depends on the agroecology, the soil type and the climatic conditions. Like for example, if it is a very high arid region like Rajasthan, so what happens when the solar radiation and temperature is very high, whatever carbon you are giving to the soil is getting oxidized. So the carbon is not stored there. For example, you go to nice cold regions and places where the temperatures are moderate, so the carbon buildup is very good. You feel that soils are moist and they are living. But in Rajasthan, if you feel the soil is sandy, I'm just giving an example, desert versus. So it depends upon the agroecology, the temperature, the climatic conditions, and the soil type altogether. That And probably there are some detailed courses which you should plan to read or understand and understand. Yeah. Organic sources. Yeah. So if you are adding farmyard manure, organic manure, those kind of sources, there is a recommended dose. For example, they say 10 tons in 1 year, you have to apply every alternate year. So that's how it is. And depending upon the source availability and supply. If a farmer cannot afford that much or it's not available, you can start small, but it will keep building. So that is one aspect. So for every crop, this package of practices, like for example, the way you grow groundnut in red soil and the way you grow groundnut in sandy soil will be different. Because that is what I told about customized solutions. And how you can do this customized solution based on the data you have. And what is that data, how is the data made available? Again, you are getting that small packets of data and putting it somewhere. And that whole data, large data is getting analyzed and it will help you. Again, you'll get the results, but then again you have to customize it and localize it. So you have big chunks of data for a very generic and a larger platforms. Again, you have to get the data, customize it and bring it for your local solutions. So this is how it works. Soil testing. So that is called carbon modeling. Soil organic carbon modeling. So Rosenstadt University has developed a model called ROCE. So that also has got modeling and data outputs, historical data for so many years. You grow a particular crop in this temperature, in this climate, in this moisture, in this rainfall. This is the yield. This is the carbon content. Like that data for 30 years. Example, 30 years, 40 years. That data is taken for simulation and prediction. And saying that, okay, if you do it next 5 years, this is how, this much of carbon you can build per year. Okay. Any more questions? We can take it after the session. I'll be available for a few more minutes. Thank you all for your patient hearing. I hope, I don't say that maybe 100% has got into your system, but I'll be really happy and glad if you have at least got an overview and understood the importance of agriculture, environment, and especially in the drylands, which are very challenging and which are the greater contributor for food production in India. So I hope this has given you some insights and triggered some thinking, and I'll be happy to interact in future also. But this session, I hope you've understood the importance and you'll take it forward on working in these lines on using this particular cloud computing technology. Okay? Thank you one and all, and have a great day.
That was quite a thought-provoking and enlightening session, ma'am. Your thinking of technology and agriculture through presentation and demonstration have given us a better understanding and clarity about the various areas cloud technology can be integrated with. I now request Dr. KVV Saraswati, Head Department of Computer Science, Bhavans Vivekananda College, to present a memento to our resource person, Dr. Padmaja, as a token of our gratitude.